Writing a recursive equation for a geometric sequence. So here we have a geometric sequence, and we know it's geometric because we're multiplying by something every time, a common ratio. So when we take a look at this, recursive just means based on the term before. So whatever the term was before, we can figure out what the next term is. Now if we take a look at this, if we know the term is 3, we know how to get to the next term because we just multiply by 2. So for example, if n equals 1 right here, I know t of 1 is 3, and if n equals 2, I know t of 2 is 6. If I know t of 1, all I have to do is multiply by 2 to get to t of 2. So just multiplying to get to the next one. So I can have t of 2, and in order to get to t of 2, I know that's equal to t of 1 times 2. I'm just multiplying by 2 to get to the next term. So I can figure out t of 2 by just multiplying t of 1 times 2. And I can do that for any term. So for example, if I want t of 4 right here, and I know t of 3, all I have to do is multiply by 2 to get to t of 4. Now we can write this in general terms. We can use t of n plus 1. That's the term after. So for example, if we have our t of 2 right here, our t of n would be 1, and t of n plus 1 would be t of 2. So notice that's inside the parentheses. So this isn't distributing or anything like that. This is just telling me like function notation. This is the term after. So in this case, when t of 1 right here, this would be t of 2, so this is t of 1 plus 1. So I'm just looking at the term after. And so we can write it just like this. I can take a term, multiply it by 2, and get to the next term. Now you can actually write this another way. Some people write it with a minus sign, where I have t of n equals the term before, t of n minus 1, so I'm subtracting. So if this is t of 2, this is t of 1 times 2. So you end up the same place. It's just another way of writing it. Our book uses this notation right here. And so that's great and all, and we can get all of these terms as long as we know what each one was, but this equation right here actually works for infinitely many sequences. I won't necessarily get that because this is telling me I just take the term before and multiply by 2. So I could have a sequence like this that would get me the same value if I just had this part of it. So it's really important when you have your recursive equation that you have a second part. And that second part should tell you the starting place, because our starting place is going to make a difference as to which sequence we're talking about. And so we just put the starting place in there. T of 1 is equal to 3. And we could actually put any term number in there and go backwards to get t of 1. It's just conventional, we put the first term in there. And so these two parts make up my recursive equation for a geometric sequence.